Solving for missing frequencies. Now, you might encounter problems where you aren't given a complete dataset. Instead, you are provided with the median of a grouped dataset and the total number of observations, but some pieces of the puzzle are missing. Specifically, some individual frequencies in your table are unknown, and we typically represent these missing values using variables, such as x and y. It might look intimidating at first, but don't worry. The trick here is to treat the problem as a system of linear equations. We are going to use two primary pieces of information to solve for those unknowns. First, the total frequency, and second, the median formula. Over the next few slides, I will walk you through the exact step-by-step procedure to find these missing values. Welcome, everyone. Today, we are going to tackle a specific type of challenge in statistics, solving for missing frequencies. Step-by-step procedure. Now that we understand the general concept of using a system of equations to find these missing values, let's look at our first practical step. Step 1 is to construct a cumulative frequency table. When you are faced with a problem where some data is missing, you shouldn't just look at the frequencies as they are. Instead, you need to create a complete frequency distribution table that incorporates your variables, such as x and y, for those missing frequencies. Once you have your frequencies listed, your next task is to calculate the cumulative frequency for each class. This is done by adding the frequency of the current class to the sum of all previous frequencies. Because we have unknowns, your cumulative frequency column will often contain algebraic expressions. For example, if your first class has a frequency of 10 and your second class has a missing frequency of x, your cumulative frequency for that second class would be written as 10 plus x. This setup is crucial because, as we will see in the next few slides, these algebraic expressions are exactly what we will plug into the median formula later on. Step-by-step procedure. Now that we have completed step 1 by constructing our cumulative frequency table, let's move on to step 2, which is establishing the total frequency equation. This step is vital because it provides us with our first mathematical relationship. Remember, the sum of all individual frequencies in your data set must always equal the total number of observations, which we represent with the letter n. To create this equation, you will simply add all the frequencies from your table, making sure to include our unknown variables, x and y, and set that entire sum equal to n. For example, if your frequencies are represented by f sub 1, x, f sub 3, y, and f sub 5, you would write the equation as f sub 1 plus x plus f sub 3 plus y plus f sub 5 equals n. Once we have established this first equation, we can proceed to step 3 to identify the median class. Step-by-step procedure. Now that we have constructed our cumulative frequency table and established our first equation using the total frequency, we move on to step 3, which is identifying the median class. This is a crucial step because the median formula we are about to use in the next slide only works if we are looking at the correct interval. To do this, simply look at the median value provided in the problem statement. You need to locate which specific class interval contains that median value. Once you find the interval where the median sits, we call that the median class. Identifying this correctly is the foundation for the algebraic substitution we will perform in the following steps. Step-by-step procedure. Now that we have identified our median class in the previous step, we move on to step 4, which is applying the median formula. This is the most critical part of the process, where we translate our table into an algebraic equation. To do this, you will substitute all your known values and any algebraic expressions we found in our cumulative frequency table, specifically for the cumulative frequency and the frequency, into the formula. The formula is median equals L plus the quantity of n divided by 2 minus CF all over F multiplied by H. To make sure you don't make any errors during substitution, let's break down exactly what each variable represents. First, L stands for the lower limit of the median class we just identified. Next, n is the total frequency, or the total number of observations in the data set. Then, we have CF, which is the cumulative frequency of the class immediately preceding the median class. Be very careful here. Do not use the cumulative frequency of the median class itself. The variable f represents the frequency of the median class itself. And finally, h represents the class size, which is the width of the interval. Once you have these values ready, we will be able to plug them into the equation and solve for our missing variables, as you will see in the next few slides. Step-by-step procedure. Now that we have used the median formula to find our first unknown, we move to the final step of our procedure. Step 5 is to solve the system of equations. Remember, up until this point, we have been building two separate mathematical statements. The first one comes from the total frequency, and the second one comes from the median formula we just applied. To find the values for both x and y, you will need to solve these two equations simultaneously. This means you'll use the value you just discovered to substitute back into your first equation, allowing you to isolate and find the remaining missing frequency. In the next few slides, I will show you exactly how this looks in practice using a real-world example. Illustrative example. Now that we have understood the theoretical steps and the formula required to solve these types of problems, let's look at a practical application. Imagine a scenario where a health clinic has recorded the weights of 60 patients. We are given that the median weight is 25 kilograms, but there is a catch. The frequencies for two of our weight intervals are unknown. Our objective for this problem is to use the information provided to calculate the specific values for these missing frequencies, which we will call x and y. Given data. First, let's note our given values. The total number of observations, which we call n, is 60. We are also given that the median weight is 25 kilograms. Now, let's examine our frequency distribution table. We have 5 weight intervals, or class intervals, ranging from 0 to 10, up to 40 to 50. Looking at the frequency column, we can see some values are known, such as 5, 20, and 10, but we have two unknowns, which we've labeled as x and y to prepare for our calculations in the next steps. I have already constructed the cumulative frequency column for you. For the first class, the cumulative frequency is simply 5. For the second class, we add the frequency x to the previous total, giving us 5 plus x as we move down. The third class becomes 25 plus x, the fourth becomes 45 plus x, and the final class ends at 55 plus x. Now that we understand the general procedure, let's look at the specific data we are working with in this example. Keep this table in mind, as we will use these algebraic expressions to set up our two equations in the very next slide. Step-by-step solution. Now that we have our table set up with the cumulative frequencies, let's move into the actual solution. Our first goal is to create our first equation. Step 1 is to establish the total frequency equation. Remember from our given data on the previous slide that the total number of observations, or n, is 60. This means that if we add up every single individual frequency in our table, the sum must equal 60. Looking at our frequency column, we have 5 plus x plus 20 plus y plus 10. When we write this out as an equation, it looks like 5 plus x plus 20 plus y plus 10 equals 60. To make this easier to work with, let's simplify the left side by combining all the constant numbers. 5 plus 20 plus 10 gives us 35, so our equation simplifies to x plus y plus 35 equals 60. Finally, if we subtract 35 from both sides to isolate our variables, we get x plus y equals 25. We will label this as equation 1. We'll need to keep this equation safe, because in the next few steps, we are going to use the median value to find our second equation so we can solve for both variables. Step-by-step solution. Now that we have established our first equation from the total frequency, we need to move on to step 2, identifying the median class. This is a crucial step because, as we saw in our procedure earlier, we cannot use the median formula until we know exactly which interval we are working with. Looking at the data provided, we are given that the median weight is 25 kilograms. If you look back at our frequency distribution table, you will see that 25 falls squarely between the lower limit of 20 and the upper limit of 30. Therefore, we can officially conclude that our median class is the 20 to 30 interval. Identifying this correctly is vital, as it tells us exactly which values to plug into our formula in the next step. Step-by-step solution. Now that we have identified our median class as the 20 to 30 interval, we move on to step 3, applying the median formula. This is where we bring all our known values together. Looking back at our frequency table and our identified median class, let's extract the specific components we need for the formula. First, the lower limit, which we call L, is 20. Next, we look at our total number of observations, N, which is 60. So when we calculate N divided by 2, we get 30. Now be very careful here, this is a common place for errors. We need CF, which is the cumulative frequency of the class preceding the median class. Looking at our table from the previous slide, that value is 5 plus X. Then we need F, the frequency of the median class itself, which is 20. Finally, our class size, or H, is 10, since the intervals increase by 10 units each time. Now, let's substitute all these values into our median formula. We start with our given median of 25. This equals 20 plus the quantity of 30 minus the quantity 5 plus X, all divided by 20 multiplied by 10. As we will see in the next slide, we will use algebra to simplify this expression and solve for our missing variable, X. Step-by-step solution. Now that we have substituted all our known values into the median formula on the previous slide, let's move on to step 4, where we actually solve for our first unknown, X. Starting with our equation, we have 5 equals the quantity, 25 minus X, all over 20, multiplied by 10. To begin isolating X, our first step is to subtract 20 from both sides of the equation. This leaves us with 5 equals the quantity, 25 minus X, over 20, multiplied by 10. To make the numbers more manageable, let's simplify the fraction. Notice that we have 10 in the numerator and 20 in the denominator. We can simplify 10 over 20 down to 1/2. Now, our equation looks much cleaner. 5 equals the quantity, 25 minus X, all divided by 2. Next, to get rid of that denominator, we will multiply both sides of the equation by 2. This gives us 10 equals 25 minus X. Finally, we are almost there. To isolate X, we can rearrange the terms by subtracting 25 from both sides, or more simply, we can see that X equals 25 minus 10. Performing that final subtraction, we find that X equals 15. Keep this value of X in mind, because in the next slide, we will use it to find our second missing frequency, Y. Step-by-step solution. Now that we have successfully found the value of X, we are on the final step of our solution, solving for Y. If you recall from our first equation in step 1, we established that X plus Y equals 25. Since we just determined in the previous slide that X equals 15, we can now substitute that value directly into our equation. This gives us 15 plus Y equals 25. To isolate Y, we simply subtract 15 from both sides of the equation. This leaves us with Y equals 25 minus 15, which simplifies to our final result, Y equals 10. So, we have now found both missing values. Let's move on to the final answer slide to wrap this up. Final answer. And there we have it. After substituting our value for X back into our first equation and solving for Y, we have reached our final result. The missing frequencies we were looking for are X equals 15 and Y equals 10. This completes our calculation, but before we wrap up, let's take a moment to review some common pitfalls to watch out for in future problems. Common mistakes to avoid. Now, before we wrap up today's lesson, I want to pause and discuss some common pitfalls. Even if you understand the steps we just walked through to find X and Y, it is very easy to make a small error that throws off your entire calculation. Please pay close attention to these 4 points. First, watch out for incorrect cumulative frequency selection. A very common mistake students make is using the cumulative frequency of the median class itself. Remember, when you are plugging values into the formula, you must always use the cumulative frequency of the class immediately preceding the median class. Second, be careful not to confuse the simple frequency with the cumulative frequency. Specifically, when you are looking at the denominator of the fraction in our formula, ensure you use the simple frequency of the median class and not the cumulative frequency. Third, keep a close eye on your algebraic signs. This is where many marks are lost. When you are substituting an expression for the cumulative frequency, such as 5 plus x, into the formula, you must always place it inside brackets. If you write 30 minus 5 plus x without those brackets, you will end up with 30 minus 5 plus x, which is mathematically incorrect. You must write 30 minus the quantity 5 plus x, which correctly simplifies to 30 minus 5 minus x. Finally, regarding the calculation of n divided by 2, always ensure you use the total frequency, n, as provided in the problem statement. Do not try to calculate n by summing the incomplete table. Use the value given to you at the start. If you can avoid these mistakes, you will find that solving for missing frequencies becomes a much more manageable process. Now, let's look at our key takeaways to summarize everything we've learned. Key takeaways. To wrap up our lesson today, let's review the key takeaways to ensure you have a solid grasp of this topic. First, remember the principle. 2 unknowns equals 2 equations. Whenever you are faced with 2 missing frequencies, like the x and y we solved for in our example, you cannot rely on just one piece of information. You must utilize both the total sum of all frequencies and the median formula to create a system of equations. Second, always remember that the median class is key. As we saw in the step-by-step solution, you cannot even begin to plug values into the median formula until you have correctly identified which class interval the median falls into, based on the median value provided in the problem. Finally, keep in mind that this is essentially a linear algebra problem. While the context is statistics, the actual work involves transforming a statistical dataset into a system of linear equations. This requires you to be very disciplined with your algebraic substitution and simplification to avoid the common mistakes we discussed earlier. If you can master these 3 pillars, you will be able to solve any problem involving missing frequencies with confidence. Great job today!